Hello, everyone, and welcome to today's SANS webcast, Modern Web Application Penetration Testing Part 1, XSS and XSRF Together. My name is Carol, author of SANS, and I will be moderating today's webcast. Today's featured speaker is Adrien de Beaupré, SANS Principal Instructor. If during the webcast you have any questions for our presenter, please enter them into the questions window located on the GoToWebinar interface at any time. Please note that this webcast is being recorded, and a copy of the slides and recording of this webcast will be available for viewing later today and can be found on the SANS registration page. And with that, I'd like to turn the webcast over to Adrien.
Hey everyone, hope you can hear me and see my screen. My name is Adrien de Beaupré. Brief requisite, who am I? I've been working with SANS for well over 20 years. Teaching for SANS for about 10, principal instructor, and the course author of 2 courses, the co-author of 460, Enterprise Threat and Resistant course, and 642, the Advanced Web Application Penetration Testing, Ethical Hacking, and Exploitation Techniques course. So this this series of Modern Web App Pen Testing will be taken from parts of 642. And one of the topics we're going to talk about is cross-site scripting and cross-course forgery together. So why this particular webcast? So years ago, and not that many, I guess, years tend to flow by more quickly at my age, we were doing a pen test, and we were doing a pen test as a team of a fairly large-scale application, and we discovered some vulnerabilities, and 2 of which were cross-site scripting and cross-course forgery. So we're going to talk about how we identified each of those and what they mean, and then how they were used together, where one is actually the payload of the other. We'll look at some code, yay code, and then do a live demo. Now, of course, with live demo, there's always some risk, so well, we'll see how it goes. So tester of the pens, that's what we do. We test pens. We take pens and we test to see how well they write. So we're doing a pen test, and one of the things with penetration testing is 1, identifying vulnerabilities, 2, potentially exploiting them to identify how risky they are based on their probability and their impact, but also how to demonstrate risk to the organization, demonstrate true business risk, organizational risk, and how to do things correctly without collateral damage. So I'm doing penetration testing again for about 20-something years, and teaching how to do so with SANS for almost 10 now, and a principal instructor with SANS. So one of the themes of 642, the Advanced Web Application course, is never ever consider vulnerabilities in isolation. Example, cross-site scripting by itself in this particular application might be medium to high. Cross-course forgery in this particular application might be medium to high, but together, when we combine them, the risk was truly critical. So you have to take into account the probability, who could do this, and how hard would it be to do, and the impact, what would it mean to the organization if they lost control of their application, and it came up with critical. So, the 3 Ps, as I like to call them, pillaging, pivoting, and passwords, are 3 of the critical aspects of modern penetration testing, where we have to demonstrate risk, but also, meet certain objectives. What does the organization care about? Why are they doing the pen test? What is their threat model? So getting down to, we did a fairly lengthy assessment of this application, my team and I, and the list of things that this one application was vulnerable to was really quite impressive. This was, again, a few years ago, but, one was content can be framed, okay, by itself, no biggie. Cross-site scripting, well, that can be a biggie, but it really kind of depends. It's one of those things we teach in penetration test classes and testing classes that, impact varies from organization to organization, the effect it has in an organization, and the probability of that attack actually be carried off easily and correctly, varies. Method interchange by itself, no big deal. Cross-site forgery, possibly a big deal. Then some other interesting ones, user enumeration. So if you clicked on the forgot your password function, you could put in potential usernames that would tell you if those users' names were valid or not. which let us pretty quickly know which account was the administrator account, because the administrator at this account actually existed, and we could tell it existed. And some weird stuff. The administrators could disable their own account. So I think what they intended to do is have a function where one administrator could disable another administrator in case something went wrong, or laid off or left the organization or whatnot. But an unintended consequence was they could disable their accounts. So cross-source forgery was interesting because all of the cross-source forgery functions were by the administrator. So individual users, cross-source forgery was not a big deal. To a certain extent, you can think of this entire app as basically email and help desk. So the help desk functions were interesting is that if you enabled the ticket or created a ticket, it would be seen by the administrator and then assign priority and then reassign to perhaps someone else who doesn't have that high level of privilege. But the fact that the admin functions were cross-forgeable possible, and within the help desk function, it was possible to cross-site script perhaps administrators, and the administrators could disable their own accounts, and of course administrators could create accounts, put accounts in the admin group, change their privileges. So there's some really interesting functions that were not accessible to users, but if you could introduce a cross-site scripting payload that would control an administrator account, all of a sudden the administrators could do all kinds of interesting things, including disable themselves. So lots of vulnerabilities, and we're sitting down and we're saying, okay, well, individually, perhaps not critical, but if you take these things into account and combine them, might be interesting. So cross-site scripting, also known as XSS, also known as script injection. So this application had a help desk function. Any user could get a ticket, and the first ticket from any user would always be viewed by someone with higher privilege in the application, like the administrator. So if we could introduce cross-site scripting into help desk ticket, the administrator would likely view it first, the script would execute in their browser in the document object model that they would control, and then the administrator account would have performed cross-site scripting payloads with cross-site forgery. So let's get this straight. So here's what's interesting. Once the attacker controls via cross-site scripting the browser of the victim, they can inject their script into the document object model, which is the browser function in that application. So in the application, we have the normal scripts injected or downloaded by the application into the browser. Then we have this additional things we can inject into the browser via cross-site scripting. So now we control this document object model. The question becomes, what can you do? Whoop. I'm sorry, that was someone trying to call me on my phone while I'm talking to you. My apologies. So the administrator can perform functions in the application, and if we can control the administrator's browser, we effectively control the application. That's the key point here, where in modern applications, the true payload of cross-site scripting is cross-site forgery, where traditionally, way back in the day, when we did cross-site scripting, we would perhaps try to grab the user's cookie and post it to ourselves, which meant temporarily we may have access to the application as that user, but it's fairly ephemeral. Now here, with cross-site scripting, the cross-site forgery is fairly ephemeral, but if we can then subsequently control the application by adding a user and then perhaps locking out the other administrator account and logging them out, that may be of interest. So cross-site scripting is interesting. I call it the user-to-user attack, where a user, for example, will bounce the cross-site scripting payload off the application, and it bounces back and runs in the browser context. That is the reflective type. And of course, there's the stored type, which we're talking about here, where within the application, you can find a function that allows you to place your script inside the application. And subsequently, any other user that sees that page, the script will execute in their browser, in their context. Of course, there's a third variant and other variants. The third primary variant is document object model based or DOM based, where literally ricochet happens inside the browser. So that's cross-site scripting. So getting back to my original point, if the true payload of cross-site scripting is cross-site forgery, what we do is we introduce a script via any one of the three primary means of injecting, via reflective, the get, via a post, perhaps to a stored server side or within the DOM, where we inject a script that pulls off a transaction in the application. So this is where XSRF comes in, crossless forgery. So while the user is using an application, the attacker gets them process scripted by whatever it means, clicking on a link thereby, or whatever it means. So let's say they click on a link. Then we now have control of the browser. With the browser, via things like Ajax or the means, we can then pull off transactions in the account. So first myth of crossless forgery. The first myth is that the user must be logged in. It's actually not necessarily true. The user has to be able to establish a session, meaning they have a stored cookie in their browser. Like, for example, some applications store cookies almost forever, and your session is always recoverable in that particular tab. Or single sign-on, where, for example, users are always logged into all applications all the time. In Active Directory, for example, if you use Kerberos or traditional tokens, once the user is logged into Active Directory, they're subsequently automatically logged in via their TGT, they can get a TGS, or via Windows tokens. They're automatically always logged into all their applications. So sign-on, or they have an existing session, and or the session can be re-enabled later. Or honestly, in the case of session fixation, if the user clicks on a link and that token subsequently becomes valid, their session token in the application, then they just log in and you get a token. So crossless forgery, that's the first thing, is that users have to be an existing session. Not always true, but it's easier if they do. Second, of course, is with crossless forgery, many people assume, well, you can only do one thing on the get or the post. And what's interesting with modern applications is with crossless forgery, you can just keep going. I can, for example, create a form in JavaScript that can do multiple posts to the application. An example, what if the application, you log in, you go to transfer funds from your account to someone else's account, and it says, are you sure? Well, if you can take control of the browser, in the first form, we submit the request to transfer funds, then we wait for that form to complete. When the second form loads, are you sure? Submit the second form, because we still retain control of the browser. So it's one of the interesting things through either XML RPCs or through Ajax or other forms of control of the browser, we can just keep doing multiple transactions. So it's how cross-site scripting, we now understand that the true payload is crossless forgery. With crossless forgery, some of the myths there about only being able to do one transaction are no longer valid. So we're pulling out transactions inside the application. So I liken cross-site scripting and crossless forgery, they're kind of like cousins. They get along really well. They're sneaky, mischievous cousins who like each other. And here's another analogy. So if cross-site scripting, right, the user sees a link of an application they recognize, it's their bank. They click on the link. So cross-site scripting is kind of taking advantage of the trust that that user has in their application they know. What they don't know is that their application is vulnerable to cross-site scripting. Bummer, right? So the cross-site scripting bounces off the server, comes back in a link into the browser, and executes. Cross-site request forgery is actually almost the exact opposite. So cross-site request forgery is where you have a valid session token for that application. You close the tab, but when you reopen that tab to the application, it's still valid. So crossless forgery is where the attacker is taking advantage of the fact that the application recognizes that user and subsequently trusts every transaction coming from that user as though it was that user, not being aware that the attacker now controls the user's browser. So that's really an interesting aspect of the two, crossless scripting and crossless forgery. They're opposites of each other. One takes advantage of trust the user has in the application. The other takes advantage of the trust the application has in that user. But together, getting back to my original example, the user clicks on a link. Now the attacker controls the browser. So another variant, of course, is persistent to min, where, for example, getting back to help desk, if the attacker can post a script in a ticket in the help desk application. Anyone who sees that particular ticket will then subsequently have the attack performed on them. But if it's an administrator, we can almost guarantee that once we get the administrator's browser under our control, we can subsequently do almost whatever we want inside the application, including, of course, administration functions, which is really super interesting. So, multi-post. This was some years ago again when we first came across this, and we knew we had some things we wanted to do. We had an objective. We wanted to introduce cross-site scripting. In cross-site scripting, we wanted to pull off cross-site forgery. But we needed code that would do more than one thing. Examples were, we wanted to add a user. We wanted to change users' password. We wanted to log out certain users. We wanted to lock out certain users. So we need to multi-post within a single transaction or a single page. So getting back to requirements for cross-site forgery, either the user is logged in, right, or they have an existing session, or a session is created for them automatically via their access to the application. And actually a subset of that is, in the case of Google, for example, if you're not logged into Google, and if it were possible to cross-site forgery attack a Google search function, and you're not required to log in, well, in fact, in that case, a session is not required. Now, the real gotcha for cross-site forgery is the transaction has predictable parameters. What does that mean? That means that to pull off the transaction correctly in your browser, the attacker doesn't have to guess. They can know every parameter. Example, transfer funds. Transfer from account, transfer to account, amount, submit. If only were that simple. So, predictable parameters, and I sometimes get pushback on that when the people will ask us like, well, how would the attacker know the parameter names? How would the attacker know valid values for the parameters? And unfortunately, the assumption there is that the attacker doesn't know. But the problem is, how do we know the attacker doesn't know? Is that a valid assumption? Is it possible that not all attackers are zero knowledge, that not all attackers are outside? Is it possible attackers either have insider knowledge or even worse, are insiders? So next, of course, is besides parameters, session, or not required, is the victim clicks on a link or types in the URL. We had one case where we did an attack. We literally put the URL in a QR code and the user scanned them and boom, the attack occurred. Or via cross-site scripting gives us cross-site forgery. Next, of course, is the transaction is something the attacker wants to do. Example, they want to transfer money from your account to theirs. I've seen many modern methods to transfer funds where they add a payer into your bill payment function inside your bank account application and then start paying themselves through, for example, credit cards. Now, the attacker has knowledge of the above or is super, super lucky. Now, I don't know about you, but I can't predict my luck. Wasn't for bad luck. Sometimes I've had very little luck. So lucky is not the way to go, right? We want to have knowledge of these things, which may mean the attacker has an account in that application, but they don't have the required access or privilege to pull off what they want to do. So they poison someone else's session, hijack their session, or use cross-site forgery to pull off the attacks in someone else's account, not their own. Graph and a slight tangent. The weird tangent is, what would you do if you were evil? I sometimes consider this if I were evil. If I could go back, for example, and change my university grades. If I could change my grades, would I make them higher? Maybe not. If I could go back and change everyone's grades and make them higher, possibly. But if you're going to go back and change everyone's grades and make them higher, to be truly evil, consider you probably want to make one person's grades the highest and one person fail. So the question is, do you make your grade the highest? And the answer is no, because that singles you out. So someone you do not like, you make their grade the highest. And someone you don't like, you make their grade the lowest. Then you raise everyone up to a B+. So getting back to the application, to be evil, we wanted to add a user. We wanted to change the user's password such that we knew that user's password. We wanted to put the user in the administrative group, enable that user, so activation required, and disable not our user account, no, disable the administrator account. There was actually a function available in this application that administrators could disable their own account by changing their own password. And most applications, when you change the password, they ask you for the previous password. This application didn't. If you were administrator and clicked on the change user's password function, you could just put in the password twice and submit. Ironically, you could also do it to your own account, effectively disabling your account. And here's another fun fact. In most applications, well, many applications we've seen, the log out button does not always have a cross forgery token or any protected means, so you can force user to log out. So put those things together. We add a user, hacker1. We change user password to evilhacker99. We put the hacker account into administrator group. We enable the account so we can log in. Cool. Then we go to the administrator account. We lock them out. I effectively change the password to something they don't know. Then we log them out. Then we log in as administrator. We're done. So these are the kinds of things we're thinking about, like how can we pull this off? How can we automate it such that one click, one administrator will pull off all these things without them being aware, and then we log in and we have control of the app. So this is what we're thinking. This is our evil scenario. So we need a demo. Now, we actually pulled off this demo in front of the management of the application, and they were quite stunned. To a certain extent, the developer group and the web app firewall group had come to management and said, you know what, those security people, they don't know what they're talking about. This stuff, not possible, not happening. We could stop them. We're like, well, you know, we're pretty sure we can do it. Why don't we do a live demo and we'll see what happens. So we pull off the demo in the live account in the real application. And people were stunned, right? Asking massive questions like, how could this possible? How is this possible? Why didn't the WAF stop it? Why couldn't you recode the application? Parts of the application were actually third-party code that we could not change, and we're trying to go to them and ask them to change the functionality. So add a user in the admin group, lock out superusers, multiple, log out superusers, multiple, get all the functions in the correct order, and each function had to wait for the last one, right? So add a user, wait. Put the user in the admin group, wait. Log out the superusers, wait. Log out the superusers, wait. And of course, one page, one click shopping, and the last thing was to make them view a certain video. Now, there was major debate within the team. Do we go the ultimate evil and unprofessional move of the Rickroll? Ultimately, we decided not. We made them see an innocuous page that didn't do anything, but the Rick Astley video, you know, arguably we, penetration testers, information security professionals, we have effectively rebirthed Rick Astley's career through the Rickroll. Well, we didn't do the Rickroll. That would be way too mean, way too unprofessional, so we moved on. So here we are. We have the ideas we want to do. So let's back up. We had the ideas we want to do, and we're like, okay, how do we do it? So we found multi-post cross-post forgery code. We already had the cross-scripting working. Tim Tomes and some older code, Ethan Robish based his code and someone else's. So we had this multi-stage cross-post forgery payload. We had the cross-scripting code working. We recoded it for this particular application, made it work. Our demo worked. People were stunned. They were screaming, ranting, raving. You know, some harsh words were said. End of the day, we pulled off the attack. We proved it was possible. The risk was there, and it wasn't all that hard. So Google came to our rescue. So pseudocode. First off, we find the cross-site scripting. Next off, we create an HTML page to inject into cross-site scripting. We create one form for transactions, so form 0, form 1, form 2, form 3. depending on the number of transactions you want to perform. You create one iframe per form. Now, we made the iframes visible for one of the proof of concepts that we ran. You don't have to, of course, make them invisible background, make users view kitten videos or bunnies or something. Then one body unload function called runMe. The JavaScript runs the code one by one in order, waiting for each one to complete. Now, hypothetically, the users could have closed the browser or closed the tab in the meantime, which might abort, but we found that didn't usually happen. As long as you made the link, suitably attractive for them to click, and made the video suitably attractive that it would distract them for a minute, like, why am I looking at bunnies? Then things would go well. So, getting back to this presentation, the actual application that was the source and the thought process behind making this presentation was, I can't use it. It's a customer's application. The team that I used to work with, we don't work together. So I need an application that had the exact same problem. So looking around, and I find this application called Amica, O-M-E-K-A. I had previously never heard of it, but as it turns out, Amica is super easy to install, and my apologies to the developers, super easy to exploit. So Amica is a free open source content management system application. You can download it from Amica. It's like one of those zip file. You basically configure a couple things and boom, you're up and running. So super easy to download, super easy to install, and super easy to exploit. Now, this is not a 0-day. In 2014, someone else discovered this vulnerability, and it's subsequently been sort of fixed in Amica. But of course, with cross-post forgery, what's interesting is most of the preventative measures, to discuss mitigation briefly, are not super effective. If the attacker can inject code into the browser and control the browser, they can pull out gets, they can do posts, they can do XSRF, right? There's all kinds of things they can do inside the browser that are difficult to prevent server side. Even so, client-side validation is also not very effective. We'll talk about them later, but some of the means of trying to prevent cross-post forgery through the referrer field check. Well, if the attacker can do a post, they can forge the referrer field. There's tokens, one-time path. There's all kinds of things you can do to try and prevent cross-post forgery. But most of them are highly ineffective if the attacker controls the browser. So Amica has cross-post forgery in admin functions, has cross-site scripting and API keys. So Amica installed, super easy to exploit. We're going to use it in our demo. Again, my apologies to Amica. So here, for example, we're logged into Amica as administrator, and we see the dashboard. Ooh, it says welcome. And within the dashboard, we go and add a user. So here, for example, we're adding username foo, display name bar, foo at, or super add user. Now, what's interesting is when you see this particular function in a proxy, you see username foo, name bar, email equals, role equals, active equals 1. This doesn't actually show there. Submit equals save changes. So if I knew that these are parameters required to add a user, this is cross-site forgery. Cross-site request forgeable because there's nothing there that the attacker can't predict or know, particularly if I have an account in the application or download a free open source version of the application and examine the source. So add a user. Looks like we can do cross-site forgery here. As administrator, to change passwords of other people, notice it says new password repeat. Right? We don't have to know the user's password to change it to something else. And passwords have to be 6 characters long. Well, that's not hard. The word password meets those requirements. So administrators can add accounts, make them active. Administrators can change passwords, including themselves. And here's looking at an OWASP app, an interception proxy. New password equals, new password confirmed, submit save password. So That's at least two of my requirements right there. I mentioned the logout function does not have closest forgery protections. So we find this persistent cross-site scripting in the API keys. So in a lot of applications, you can use the web application itself, the HTML interface or HTTPS interface, to interact with the application. In many cases, you can export, or in this case, go into the application, find the API key button, find your API key, and then do, for example, curl or other means of doing REST or SOAP API calls to the application, not through the HTML interface. So in this case, you can set or create API keys using the API keys function. If you put in a script into the API key function, if that user clicks on their API keys, all of a sudden the script runs in their context cross-site scripting. Now the payload, of course, of the cross-site scripting becomes the cross-site request forgery code. So I'm going with this. Now, as an administrator in Amica, you're allowed to see other people's API keys. So imagine you go into your application as your user account in Amica, put cross-site scripting in your API key, ask the administrator, hey, there's something wrong with my API key. They go look at it, boom, cross-site scripting fires because cross-site scripting is in your API key. My apologies again, someone else is calling me. That's the drawback of calling in your cell phone while you're talking online, but I had a problem with my headphones. Again, not relevant, but my apologies. So you put in cross-site scripting in your API key, administrator sees your API key, cross-site scripting fires, cross-site forgery happens, they are locked out, and you now have control of the application. So here, for example, we actually did the cross-site forgery attacks in iframes and made them visible when we pulled off the attack. So we popped up all your base belong to us. Now, in a normal attack, of course, you wouldn't do that, right? You would put out something innocuous that the attackers, would take advantage of the user's cross-site scripting and show them again bunnies or kittens. So all your base belong to us. Very popular meme. So the proof of concept code showed the attack. Now we used visible iframes. You don't have to do that, of course. You make them invisible. Have the victim watch a video, whatever that may be, or some sort of game, flash game, whatever. And of course, rickrolling is mean. We don't do that. So we're up to cross-site forgery token and prevention. So random non-zero token is the only real defense, except if the attacker's inside the DOM, they can read the token value and play it back. There's the refer fields, there's origin headers, there's CAPTCHA, there's have the user put in their password again for reauthentication, there's one-time paths, there's all of these attackers try and get around, but also the users don't like them. So user experience. And again, ask them to submit the Are You Sure form can be bypassed using the lowest post technique. So cross-site forgery defenses, you can try using 1, 2, 3, or even 4 or more of these defenses. Individually, they're all bypassable. Taken together, they are harder. But once the attacker is in the document object model controlling the browser, there's not really a lot of good defenses. Right. Now, quick comment. This code and this talk are all online. I've given this talk before, as my friend Kevin mentioned, in Facebook. And this is just a modern update. And we're going to now commence the series of these talks on modern web application penetration testing. And I'm going to do a demo. And a quick comment about demos is I always ask for a goat, virgin goat to be sacrificed, but they always say no. So no actual goats are sacrificed to the demo gods. And it's just a joke. So if you have any questions, get them ready because I'm going to switch over to demo mode, do a quick demo of the code. So now you should be seeing my VM screen. This is just an example of in the API keys. So what you do is go into your own API keys and put in script location.href, the location of the HTML form that submits itself in the script, and then as well, you can add cross-site forgery code to add your attacker script to the administrator's API keys. So if they ever go into their own API keys, the attack runs, which is, you know, ironic and funny. So here we have, I want to show you the actual API code. So the code of the exploit, which is again online on the blog posts I mentioned earlier. So here, for example, we have a form number. So here's the run me on this line. There's form 0 that adds a user. There's form 1 that changes the administrator account user password. Now in Amica, the user is always number 1. So this particular function, admin users change password /1, always changes the administrator password to the value of PASSW0RD. And the last function logs them out. So we're doing create the account, right? Add in the super user group and make them active. Then we should probably try and figure out which account number that is and change their password, but we didn't do that. Change password administrator and log them out. So this is really straightforward code. Run frame 0, frame 1, frame 2, all your bases belong to us, and you're done. So really simple code. So here we're logged in as administrator. We can go to items, we're in collection. This is just, you know, all the stuff inside the application, right? So go to welcome super user. Here's administrator, super user administrator, right? Change password. Notice that it does not ever ask you for your own password again. API keys will fire the attack. Are you ready? Go to API keys administrator. And wow. See how function 1 ran, function 2 ran, function 3 ran, all in frames, and then we were logged out. So let's log back in. Administrator. Notice it will be with PASSW0RD, which is the password set by the attack. For whatever reason, Amica kind of pauses here for a sec, even though it's running on localhost, which it shouldn't, with plenty of RAM and whatnot. So it just seems to take for a sec. Let's go back to that login. I'm currently accepting the Burp Suite with Burp Suite, the community version. So here's a get to admin. Right? Here's the request. Nothing special. Looking for, here's the post to log in. There's the request. Administrator, password, PASSW0RD, that's the password set by that code we just saw. Number 0 to make them log in. So now we're logged in, right? Now, example, if the user had clicked on a link, for example, attacker /Amica-exploit.html. This would be an email that clicked on a link while they're logged into Amica. Same thing happens, right? Locked out, logged out. So that's pretty much it for my demo. Quite a simple code. All the code's online. If you have any questions, please feel free to contact me, either through the question asking function inside the webinar. There's my email address. There's my cell phone number. There is my Twitter handle. I'm an independent consultant. I live about a quarter of the year in Ottawa, Canada. The other quarter of the year I live in Plano, Texas, and the other half of the year I travel around the world teaching for SANS and doing consulting work in application security. So that's it for me. Are there any questions? We have plenty of time for questions, so please do feel free to either call them in or to type them in to Carol.
All right, well, Adrien, you took the words right out of my mouth. Yeah, go ahead and put any questions into the questions window. We do have a couple that have been submitted. The first one asks, what would be the best type of penetration test to do on a banking application by a vendor? Also, what are some things that vendors sometimes forget to do?
Okay, so it sounds like the question is, Can we do pen tests on a vendor's banking app? With permission, of course. So application pen testing covers a large number of different types of attacks, and the types of attacks are driven by what is the threat model? What are the types of attacks that are of concern to either a vendor or to yourself? Now, in the case of if you don't get permission to do pen testing of their app, you may have to do a third party, SOC 2 or whatever they're called now. And getting back to, OWASP, the Open Web Application Security Project, they have a number of different listings of testing guides and things to assess when you do application testing, static code analysis, dynamic code analysis, and testing. And I'm hoping that answers your question.
All right, thanks. Do you have any good, I'm not sure this is one we can ask. Let's see.
Oh.
They're asking about a specific, they're saying, do you have any good vendors that SANS can recommend at this time? But I'm guessing that's not something we can address. What would be the remedial? Go ahead.
So I can briefly mention that a lot of the SANS instructors themselves are available and are vendors. I don't mention names, but there are a number of SANS instructors who run companies who do pen testing.
All right, thanks. What would be the remediation for this particular chain of exploits?
Okay. So getting back to process scripting gives you process forgery. So true mitigation is actually looking at the process scripting first. There are two primary means. First is input validation, input sanitization. Make sure that the fields that the attackers can get at and input are first validated. What are they typing in? And sanitized, removing certain characters like less than, greater than. But also output encoding. If you output and encode things that are inputted by the user into the application, when they come back, if they're encoded, they don't execute as a script in the browser. So input validation, output encoding for cross-site scripting. The second part is the cross-site forgery. You can also attempt to mitigate cross-site forgery by adding in, as I mentioned, that random nonce or per instantiation, so per form, add in the cross-site forgery token every time.
All right, that's all the questions that oh, no, one just popped in. What is severity level of this attack from OWASP standard?
Okay, so looking at the OWASP standard, you typically put things in a matrix, right? The matrix is probability and impact. So the real answer, it depends, because you have to map out the probability. How hard is this attack to do? Well, cross-site scripting, if there's no mitigation of input validation and output encoding, may be fairly high probability. And then impact of the cross-site forgery can be high, depending upon the user that's attacked and what they can do in the application. So getting down to the matrix, it can be typically either medium high, or high, which is basically critical, right? So it's a matrix of assessing risk. So the answer is there's no one answer. It depends. Usually fairly high.
All right. Someone says, sorry for the ignorant question, but would you please explain more about what is meant by output encoding?
Output encoding, yes. So output encoding means certain characters are not output as that character. So less than is output in a URL encoding as a particular value that will not execute in the browser. So less than, the word script, greater than, if it's not encoded, will be run as a script in the browser. But if you output encode using URL encoding, it'll be shown in the browser literally as less than, greater than, script. So less than, script, greater than, but not actually execute. That's what that encoding means.
All right. Someone says, did you say that SAST/DAST should be part of the pen tests?
Actually, I'm going to take that back and kind of say that pen testing, SAST and DAST are part of an assessment, to be more specific. If that's what I said, that's not what I meant. So I'm also the author of the assessment course, in which SAS and DAS become part of assessment, which may also include pen testing.
All right, that looks like all the questions that have been submitted. Do you have any closing thoughts you'd like to share?
So web app pen testing and assessments of applications, which includes static and dynamic and other things, code walkthroughs, etc., are a fascinating topic. And what we want to do is explore modern web application penetration testing and assessments. This is part 1 of the series. We're going to try and do them on a regular basis. Please do tune in. Also, please feel free to reach out to me, email, Twitter, and cell phone. And I teach 642, the Advanced Web Pen course, on a regular basis around the world. Thanks.
All right, well, thank you so much, Adrien, for your great presentation, which helps bring this content to the SANS community. To our audience, we greatly appreciate you listening in. For a schedule of all upcoming and archived SANS webcasts, including this one, please visit sans.org/webcasts. Until next time, take care, and we hope to have you back again for the next SANS webcast.